Tidy and the Virginia Tech Corps Cadets. And this past weekend, we just got a new golden doodle puppy, which is now named Hokey. With that, we'll move on into the presentation here. Always like talking about Dr. Deming, talking about what is our aim. So this is a relatively technical topic. We're going to talk about some appreciation for numerical data, bring in some fairly old information about statistical process control. We're coming up on about 90 years since Dr. Shewhart originally developed that, and of course we can do that a lot faster these days with Excel spreadsheet and other tools. We're going to bring in information from Dr. Shewhart, Dr. Deming, and also hopefully some of you heard Dr. Ackoff, who was heavily involved in systems thinking. With all this, the goal being making better management decisions and assisting in better management decisions. We don't want to be completely 100% numbers oriented or repeat the bad lessons of the Vietnam War days with Robert McNamara, but we do also want to be able to not just fly by the seat of the pants, but to have some grounding in the data, or Fluor Corporation is actually saying they want to be data-centric. And so this is a bit of a marriage of a rather soft skill, which is the red, yellow, green color coding for executive summary, but making that based upon statistical process control. As mentioned, feel free to type in a chat question. If there is something that's timely, I'll kind of answer it as we go, but generally we'll have a question and answer period at the end. Not going to get... I can't hear you. I'm sorry? I just heard somebody say something, but okay.
Continue.
Okay. In statistical process control, perhaps at some future date, if people like to get more involved with that, we can do some more problem solving, or actually how to make a control chart, or put that chart we saw at the beginning as a statistical process control chart. But it is a way to present data. It's a objective method to find out if you have a trend versus are you stable. Now, hopefully most people have heard the definition of insanity is continuing to do what you've always done before, but expecting the results to be different. So we definitely do think about stable processes here. This is also tied to capability. Not only are you stable, but are you stable the way where you want to be? I can be stable and predictable and killing 3 workers a year, but that certainly would not be acceptable. And this is also a way of thinking.
We cannot hear you.
Hello?
I'm not sure what's going on here, Steve. Who is speaking? Okay. Well, if somebody has an issue, please use the chat box. We got a lot of folks online here. We would not, we really don't appreciate your interrupting every few seconds here. So please use the chat box if you would, please. Steve, please continue.
Okay. And it looks like from the chat box, a lot of people can hear. So we'll continue onward. So as described in the introduction, this work started actually at Hanford, Washington. When I was over there, was actually hired as a maintenance supervisor, got diverted into the metrics pretty quickly. And through the Fluor Corporation, I'll give you a quick advertisement for them. Big construction company. We have a government group within it, and we work a lot of energy sites. Probably the best project we've got going right now is we are building the new Tappan Zee Bridge up north of New York City. About half of the bridge, I think, is in operation, and now they're tearing down the old bridge to build the other half of it beside it. This presentation has the Canadian Nuclear Laboratories logo on it because that's kind of the biggest current project we have going with this methodology. I think there probably are some CNL employees listening in, but we also in South Carolina use some of this at Savannah River Nuclear Solutions, also the Portsmouth, Ohio contract. We just finished up a Paducah contract using some of this method, and going way back, Fernald, Ohio was a nuclear site that Fluor cleaned up, and we use this method at it. I also did want to point out Schlumberger has read some of their oil research firm, and they've read some of the magazine articles and use it for their safety and health. So we have a little background as we move into this. If you've never heard of Dr. Deming's red bead experiment, it's well worth reviewing it. There's a link on this page that gives you a version I did. And this was based at a safety conference many years ago at Hanford, and the little picture there is me berating a willing worker. I do like the guys sitting in the wheelchair kind of leaning back. So I must have been doing a pretty good job of being the fear-mongering foreman. But it's if you have problems with getting people to move into statistical process control or thinking about Deming methodology, the red bead experiment is a fine convincer of it. I will admit at Hanford, I spent 7 years trying to convince people the technical merits of doing statistical trending, but 6 months of doing several red bead experiments was much more effective. So we are doing trending, and so if we talk about if you've ever suffered through Stats 101, you have the type 1 error where I think something is going on, but it isn't, and of course the type 2, which we're always afraid of, is, oh, something is going on, something's changing, but I've missed it. We probably tend to, as an American culture, lean towards, well, don't just stand there, do something. And that can lead to, if you ever want to do some further reading, read about the funnel experiment in tampering, talking about Dr. Ackoff and Dr. Deming. We do point out that if you try to react to something as if something special has happened, you will make a mountain of a molehill. But if you do miss an emerging trend, and it's so important to try to catch these changes when they start, you'll allow that molehill to grow into a mountain. Or I was in an organization, the phrase was, don't let the bunny rabbits grow into dragons. More specifically, from Dr. Deming's terminology, a special cause variation, which means I got something going on. I have a statistically significant trend. This result that I just got is not from the normal process. We need to figure out what changed. Versus the much more common cause variation. In fact, Dr. Deming, before he died, came up with 94% of all of our process problems come from the process itself, not from the individual action of a worker. So therefore, since management owns the process, management needs to take charge and lead change of the process so we get different results. So most of the time we are actually stable, and we have to determine if we're where we want to be. And if we're not, no amount of setting arbitrary targets is going to change the process. In fact, it'll probably lead to falsification of data and other artificial manipulations. So what we have in terms of the importance of this is, unfortunately, many of you have probably been to your mandatory monthly safety meeting or a budget meeting where a table of numbers is put on a PowerPoint slide, and some senior person points at this number that's 10 and says, well, 10 is higher than 8. And the reason the 10 is higher than the 8 is we had 2 more people slip on rocks, or whatever is the explanation of the random stable process. And I hope you have seen over the years that reaction to individual events that are results of a stable process generally don't lead to improvement of the process. However, again, we want to catch the initial signs of a change in the data, or we will accumulate much higher losses. So quickly, here is a control chart. The basic things on this, going back to some of Dr. Shewhart's work, we've brought into our procedures is saying plot at least 25 months of data. I've unfortunately been involved with a lot of groups that insist on doing either a year-to-date chart or a past 12 months chart. Go back to the primary data. I will say something I learned from the Deming electronic network was if you really want to understand statistical process control, go back and read the original 1930 book. The American Society for Quality reprinted a copy of it in 1980. It'll be interesting to see if they reprint it in 2030. So we do want to plot the data as is, no moving averages, but we do calculate this heavy solid line that's in the center. This is the average of the 25 data points. And so it's amazing here. It just goes right through the center of the data like an average should do. This is your statistics lecture that says, well, about half the points are above average and half are below. You can count that up. Of course, somebody may jump in and say, but that's the median. However, usually median's pretty close to the average. So we have the center line of the data, and we know what the average is. And again, half are above average, half are below average. That doesn't tell us much, but what Dr. Shewhart really came up with, and it's interesting to read in the 1930 book why he chose three standard deviation. He did a lot of math. He did a lot of what we would do now with a computer random number generator, but he actually drew hat tokens that were numbered out of a hat. I should point out he tested this against a normal distribution and a square distribution and a triangular distribution. So for those people who say, well, I can't do control charting unless it's normal, well, Dr. Shewhart, when he set this up, made sure to test it against non-normal distributions. And if you've heard of Dr. Wheeler, a current statistician and author, he's done a lot of testing on non-normal distributions and have found the three standard deviations works just fine. So we do calculate the standard deviation of the data, perhaps by moving range or by standard deviation or by the Poisson being the square root of the average, and set our three standard deviation alarm limits. And we set up a set of rules to detect trends. Why three standard deviations? Got ahead of myself a little there, but unfortunately, many courses incorrectly teach the control limits cover 99.7% of the data. That's only true if it's a normal distribution. That piece of training has hurt statistical process control, because I've heard many people go, you mean there's only a 3 in 1,000 chance of detecting something, which is a kind of a misinterpretation in itself. And then they go, well, I want to be better, so I'm going to drop that down to 2 standard deviations. Or the U.S. government actually for several years is publishing a report with 1 standard deviation control limits so they would be more sensitive and detect change. Well, all they did was to have about a 33% rate of detecting so-called trends and chase their tail all over the place, much like my puppy chases its tail, with very little result. So if you go back and look at some of Dr. Wheeler's work, he says that the rate can be as low as 95%. And if you go back to Dr. Shewhart, he invokes the Chebyshev inequality. It says up to 11% of the data can be outside of 3 standard deviations. So that 3 in 1,000 is really more like 3% or 5%. We also want to set up a list of rules. So most people have probably heard we also use, it depends on the author, 7 or 8 or 9, the same side of the average. Atchison Duncan uses 7. I primarily use 7. Dr. Wheeler uses 8. Minitab and the Western Electric rules use 9. And since those rules were in place at Canadian Nuclear Labs, we use 9 there. As long as you pick a consistent set of rules and it's not too restrictive. I've seen some people say, I've been to a conference and somebody says, oh, we're trending our data and 3 points the same side of the average is a trend. Well, good luck. About 1/8 of the time, you're going to be declaring trends. And I also, when I talk statistical process control, use the smoke detector analogy. Everybody, hopefully, wherever you're sitting right now, I ask, is wherever you are, have a fire someplace in that building or house? Well, hopefully, since you're still in the building or house, you say no. And I say, well, how do you know that? Well, my fire alarm's not going off. You trust your alarm that when some unusual level of smoke, or if you have a carbon monoxide detector, appears, then you will react to it, and you will take appropriate actions to evacuate the house, call the fire department, let the experts come in and do a special cause analysis and say, do you have a fire? If not, or it was a fire drill, we re-enter the building once the exercise is done. But if I were to take apart the smoke detector and adjust the internals so that it would alarm at a lower threshold, you would think that would make your house more safe. Well, no, it'll make it less safe because, a couple times a day your smoke detector goes off, and what will you end up doing? I don't get to hear the response, but I know hopefully you're thinking, well, I'm going to pull the batteries and throw it out. So therefore, it just gets tossed. Rather than going through the specific rules, again, just keeping this at a 10,000 foot level, this is a nice graphic I like to use. It says in statistical process control, we use a suite of rules, such as a point outside of 3 standard deviations, going back to Dr. Shewhart, Many people use 2 out of 3 points at 2 standard deviations outside the average, or 4 out of 5 outside of 1 standard deviation, or again at Canadian Nuclear Labs, we're using 9 points the same side of the average. There's a couple other rules out there that usually show up. I'll use a 10 out of 11, for example, same side of the average. The point with statistical process control is that we can detect not only a big short-term shift, but a very subtle long-term shift by this suite of rules. I see a lot of people use moving averages. I usually, if I'm in an audience, ask, okay, how many people's employers use moving averages for various things, such as injury rates? And all a moving average does, especially a 12-month rate, is, okay, it compares this month to the month that fell off 13 months ago. If this month is higher than 13 months ago, the moving average moves up. If it's lower, the moving average moves down. Think about it. That's all a 12-month moving average does. So you might as well manage by getting a handy coin out, save all the time making a chart, and flip a coin to say, am I up or down this month? So as we move into the actual meat of this, I do want to just point out, with using statistical process control for trending, we can reduce the knee-jerk reactions to the latest events. We can detect changing conditions early and reliably, and focus upon the system and what do I need to do with the process. Is something changed that I need to find and undo, or is this just a normal process result, and the only way I change my results is to change the process? And we have saved a lot of time and money over the years. One story I do tell is a facility at Hanford was taking 40 hours a month to review their radiological data. It was about 20 charts, but seemed to take a whole week for the person doing it because management would go, well, can you make this a pie chart? No, that doesn't work. Can you make it a column chart? Can you make the background mauve? All these, can you do this, can you do this, that weren't really getting you anywhere with the data. The person there called me for help. I said, well, just ship me your log. You got it in Excel. I'll make some programming and do X and statistical process control. We reduced the 40-hour a month work to 15 minutes a month. It was, if you started a stopwatch and time you emailed me the data to the time I emailed it back, it was 15 minutes with 20 control charts. And a objective evidence in terms of is there a trend or not. So the SPC actually, when people ask me how much does it cost to do it, I go, it will save you money. So we're good now. How do I though present these results? SPC scares a lot of people for some reason. So, pardon. We are going to bring in the idea, which has been around for a while, the balanced scorecard. A couple of business articles came about that in the early 90s, but we're going to use the common standard of red, yellow, and green to say, well, do I think there's something happening? Yellow being somewhat in between, and green being, okay, we're in pretty good shape. So we're going to use in this table, if there's nothing else that you take away from this presentation, ingrain this table in your head. This is the basic system, so I'll take a minute with this slide. I have a control chart result, stable or is there a trend? Now this is the analyst's decision using the trend rules. I say, well, yeah, I got a trend. And let's say I'm plotting injuries or maybe quality defects. Let's do quality defects. If I'm plotting quality defects and I'm getting more defects, I'm going to assume that's adverse. I'm going to color it red and say we ought to understand where these quality defects are coming from and consider if we need a corrective action. Now, if come to find out, somebody invoked a new set of assessments and said, I think we got a problem here, we better go look for it. Well, indeed, this may not be an adverse trend. It may be we got the response we wanted, but this does give the feedback of, yes, you did get an increase in finding of quality defects. And if it was due to a change in the assessment program, we can go, we now know we have some problems over here, and what are we doing about it? Conversely, we'll assume if we have less quality defects, we are green, that we ought to learn, well, why do we have less quality defects? And if this is a good thing, we should reinforce that from our lessons. Now, if we find out that And then my mentor, a guy named Phil Monroe, tells this story, is the commanding officer of an aircraft maintenance facility. He said, the next sailor involved in a quality defect goes to Article 15 captain's mast. Well, guess what happened to quality defects? They went to 0. Were they still occurring? Well, yes, but obviously the people doing the work dealt with it themselves and said, there's no way I'm writing this report. And so that was a very interesting lesson for a United States Navy captain. He ended up learning a lot from Dr. Deming, and if you ever do, you can find some interesting speeches he's given. A guy named is Phil Monroe. He also gave a presentation that's on the Deming Institute site. So we do want to, even if we have an improving trend, take a look and say, why did I get the improvement? Is it for the right reason? Now, again, about 94% of the time, your system is going to be stable. Even if nobody's been controlling it, most of these systems reach a natural level of stability. And so if we have the stability, and we know our average, and we know our control limits, we need to make a management decision of, is this acceptable? Can I keep doing this from now and forever? And if so, then we call it green. All we got to do is don't make any changes, or if we detect an adverse change, deal with it. Now, if the level's not acceptable, it's yellow, which means it's just the code for I need to change the system. Notice the difference between red is correct for whatever changed, and yellow is improved the system. I also, being a guy who deals with a lot of injuries, I talk about, well, if we had 10 deaths a year, occupational deaths, that would obviously be yellow. I have to admit, oil rigs are a very dangerous job, and I actually, when I was helping Schlumberger Corporation, ended up making a statistical process control chart of the number of occupational deaths. Not a fun task to do, but to try to understand it and obviously prevent them, we had to understand, did we have a stable system or not? Now, if I had 10 mosquito bites a year, that would be a completely different issue. So there's a little bit of risk in here, 10 occupational deaths versus 10 mosquito bites. Of course, having just been down in the Caribbean and all the talk still about Zika and various viruses spread by mosquitoes, there are sometimes mosquito bites might be a problem. So this is the basic color coding system. Is red if you're going the wrong direction, yellow if you're stable where you don't want to be, and green is either, well, you may not be where you want to be, but you have an improving trend by the rules of control limits and 7 in a row or 9 in a row, and also am I stable where I want to be. That can also relate to process capability. So let's move on. This is a very early model we had at CNL, so I don't have too much fear. It's changed a lot since then. We're up to more than 1,000 charts, by the way, and each of those little cells represents a chart. What we did is we started developing this. We had our various organizations. We had some lagging indicators about injuries and the reactor trip and significance level 1 and 2 deficiencies, and some leading indicators about how were we dealing with corrective action management called impact, what percent did we self-ID things, how many observations we're doing, and percent of observations that generated an impact. So this was the very early start at CNL. If there's some CNL who are on the phone call, hopefully you remember this from about 2 years ago. Now, the idea was that we could then click on any of these colors and would bring up a page of charts. So here's the upper left, for example, is something that they track called event-free day resets. And in fact, they had lowered the bar on what got counted. So actually, this increasing trend's a good thing, but it was still higher than their stated goal. And I can tell you in recent charts, you'll notice this chart ends at December 2015, the event-free day reset level is much lower. And they also track some lower level event-free day resets. So this is a fairly aggressive metric. And we also pair this with some more from Pareto charts to say what organization is it? Well, obviously operations tends to have events. And then we also have what's the reasons for the site EFDRs, like the leading one was LTI is restricted work days, lost days. So with that, people could understand where's their data coming from and what's their trend. A little discussion about goals. sometimes it's hard to get people to decide on a goal, so a lot of times we'll develop a chart of a metric they want and say, well, is this right now stable where you want to be? Now, a lot of times we will assume the initial baseline is acceptable since in the facilities I'm at, quote unquote, we're not in jail. If we were getting customer feedback or other things that said this was an unacceptable level, that would tend to clue us in that we need an improvement. But generally speaking, where we find the data, we will put that as a goal. Now, I will say at Canadian Nuclear Laboratories, pretty quick into it, the Vice President of Safety and Health set an injury improvement goal based upon some benchmarking of other places. He decided that it was worth embarking on an improvement in injury rates. So right now the injury rates are yellow, stable above the stated goal. And we're working on, well, what do we need to do to change the process to reduce injury rates? All right, let's just walk through, this is a pseudo animation here just to show you how this works, and then we'll be through this. So let's say we start with a process that is green. This month's not part of a trend, and the baseline average and control limits are on or better than goals. So green, life is good. But let's say something happens. So I'm using injuries here. Let's say injuries go above the 3 standard deviation upper control limit. We had an unusual number of maybe heat stresses over the summer, or it being Canada and we're heading into the snow, slip, trips, and falls on the ice, let's say, can happen in the winter. Let's say that injuries go above the upper control limit. Well, immediately the chart will be made red. Now, I do know when we compare these charts against 12-month moving averages, the 12-month moving average usually doesn't move that much on an individual month. So having the individual months plotted and actually the trend rules used will give you a much quicker and more accurate detection. So, okay, the chart goes red. And what we need to do is get back to that special cause. I may get those Pareto charts. Well, what are the body parts that are being injured? What's the location of the injuries? What's the cause of the injuries? Things like that. And we may have some expert opinion. Well, let's go out and observe work in progress and see what the risk we're having. This is an older story going back to Hanford, but in one of the nuclear handling plants, they were using what they call long poles. There was stuff underwater that was very radioactive, and they were manipulated using 20-foot long poles. And actually, I should say, there was supposed to be automated equipment to do this, and it broke about halfway through the project, so they had to shift to the 20-foot poles, and they had all sorts of rotator cuff injuries because of the use of the poles. They weren't at the right height and things like that. And in fact, that was a case where the 12-month moving average had it moved, but the control chart had. So us as oversight were able to say, yeah, you have an increase in injuries. And come to find out there were some very inexpensive fixes for, like, move the handle height on the pole so that it matches your body height, things like that. So we do things like, okay, an ergonomic assessment, figure out how to do this better. By the way, an impact is what they refer to as a corrective action document in Canada. So we'll take corrective actions and manage it in the corrective action management system. Now, hopefully, those corrective actions work in a timely manner and injuries return to normal and we go back to green. So life is good. We were able to detect the increase in trend. We were able to do a special cause analysis, say, well, this increase in whatever or decrease is due to the following. Let's fix it. Find it, fix it. Fairly simple. Now, this is where it gets a little tougher. Let's say we start with green, and yes, again, we go above the upper control limit. But our corrective actions don't work. We're either ineffective at finding out why injuries are higher, or maybe we took on a new product line and it's just a riskier piece of work, and we maybe didn't plan for the new work properly and injuries stay at a high rate, such as those rotator cuff injuries, and we had to shift to long poles at the other location. So at some point in time, though, the increase in injury rate stabilizes out. Whatever caused the change, and we haven't corrected for it, the new data stabilizes out. And we look at, okay, when does this stabilize, and can I put a new baseline average on it? So I will establish, working with, okay, we understand that something changed. We have a good idea what it is. Here's the new baseline average. Now, I will tell you I'm dealing with things like injuries and other sociological indicators other than, okay, I'm making a 3 ohm resistor and suddenly the machine's making 4 ohm resistors. Simply take the little dial that controls how much resistance there is and dial it down. This is more for the sociological type of trending. Obviously, if I have machinery and I can just change the machinery, I'll do that. Unfortunately, I wish there was a master dial to reduce quality defects, to reduce injury rates, to reduce many of the problems we see at work, that I simply can't go to a control and say, reduce the number of injuries, ta-da. So let's say we stabilize out at a new rate. Well, now we look at, okay, where was our goal for this? Basically, we're at a worse level, but is this still acceptable or not acceptable? And that's a management direction. Now, maybe it was not a severe shift and we had done some improvements before, and we're still, although a little higher than we were before, we make the decision this is an acceptable risk, and we will recolor the chart back to green once I have a new baseline average on it. If on the other, and then we return to the start of the cycle to monitor. You'll see I'm doing this very much as a cycle. Now, if the new baseline is not acceptable, we go to yellow, and we say the system is stable now at a higher level, which is above the goal, the wrong side of the goal. I can't meet the goal, and therefore I need to do a long-term common cause analysis and a causal analysis of how to change the system. So don't just look at what the recent changes were, but the duration of the change that has occurred, and say, how do I get this new system back to the old system? Now, let's say I get an improving trend, like 4 out of 5, 1 standard deviation below average, because this system improvement has worked. Now I'm back to green with an improving trend, and that will stabilize at a new level. And again, I'm back to the question of, is the baseline acceptable? Yes, green, and go back to the start of the cycle, versus no, it's yellow, let's do another improvement cycle. Also, if you are starting with a process that's stable and not meeting its goal, this is the same cycle here. I'm yellow, I'm stable, not able to meet my goal, whether you're just comparing the average of the goal, control limits of the goal, or you're doing a process capability. I'm stable, not meeting the goal, I'm yellow. What do I have to do to change the system, generate that improving trend that proves I changed? Then I get to the point where the data are stable, and I add a new baseline average control limits and say, yes, I've achieved a sustainable result. Not only did I have the improving trend, but it stabilized out at a stable level that's better than goal, or maybe not better than goal. So again, once I have a new baseline, I compare it to my goal and say, am I green, or am I back to yellow and need another improvement cycle? I see I'm at quarter of, so I'm on pretty good timing here. So what I do want to do is open this up for questions. Now, I will admit to you the act of how to establish control charts, how to tell if you should re-baseline. If you do Google, my name's pretty unusual, Prevette, P-R-E-V-E-T-T-E, kind of like Corvette, and put in SPC, you'll find a number of papers I've done out there. Obviously, up at Canadian Nuclear Labs, we did a full day of training on how to do baselining. I guess I will say I've previously done for the ASQ section in Washington State an 18 CEU course on statistical process control and metrics, of which this is one piece of it. So as I come to close here, and I see we're at 84 attendees, so hopefully that's a special cause variation on this, that we're at 84. And so manage your numbers instead of your numbers managing you. And I see a chat has just popped in, so I'll take a look at that. I'll say statistical process control, yes, has been around for a long time. And in fact, somebody asked the question, has there been anything in the pipeline to replace control charts? Well, as holding a master's degree in operations research, I mean, my master's thesis used logistic regression, which is also a fairly old tool, but has its purposes. You also run into all sorts of trend analyses and statistical testings and things like that. So there are definitely and even versus the statistical process control charts, there's the Q-sum chart. The one thing I say, and this is while holding a master's degree in operations research, is all that stuff's well and good, and in some specialized cases where you have a really subtle signal and you're possibly doing research, it's well worth trying to go to those more advanced statistical tools. However, I really haven't found anything for communicating with a worker that's better than statistical process control. It's amazing how many managers say, well, the worker will never understand SPC. And I show the chart. I say, well, here's your results. Here's the average control limits. You're basically between these two control limits. And the worker says, exactly. I've been trying to tell management that for years. So I do want to suggest to you that SPC is a good balance between a statistically rigorous method without getting into, well, I've got a 96% confidence that at 3% of the time that my reject the null hypothesis. You definitely start losing people very quickly. So the SPC, I think, is good for that. Is it difficult to find different interpretations of the same control chart? Well, as I said, for one example, many locations I use 7 points in a row, the same side of the average as a trend versus 9 points in a row. It depends on where you want to go there. Obviously, the 7 might be a little more able to pick up something earlier, but it may also false alarm. The main thing is whatever location you're at is make sure you decide on your rules and stick to them so you don't have what I call battling charts. Nothing is worse than having the control chart say, hey, by our established procedure, this is a trend, and some yahoo holds up a 12-month moving average and says, well, this hasn't moved. So it is helpful to have at least the operational definition of was a trend. Oh, I didn't remove the U in there. I did try to Americanize the presentation, but yes, we can use color-coded control charts for management action and feedback. Let's see, I think I've answered 2 questions here. Does anybody want to, do you want to open up the line for people to ask questions on the telephone?
Sure, if somebody does have a question they'd like to ask verbally, you can take your phone off of mute and ask Steve, but then once you've asked your question, please return to mute so that way we don't get a lot of unnecessary background noise.
And if anybody's here from CNL, please jump in to say, yeah, we really are doing this. I'm going to wait a few more seconds here.
Yeah, and as we're waiting a few more seconds for another question to potentially come in, I'd just like to remind everybody once again that there will not be a webinar next week. It's the Thanksgiving week here in the United States, so we're hoping everybody has a happy Thanksgiving next week. We will have our last webinar for this month on November 30th. Which is 2 weeks from this coming Thursday. So many of you, it looks like, are registering for that, and we welcome you to join us for that on the 30th.
Well, and you're going to pass out you're going to make a PDF of the presentation and let people have my email, right?
Correct. Correct. If that's okay.
I do find in some of these presentations, and especially I do teach some evening courses in statistics, doing an information technology course right now for SIUC, and a lot of times this stuff, all this is interesting, but what do I do with it? And you may not think of something for a couple of days, or one thing I would recommend if you're interested in this is go watch the red bead experiment video. That will help kind of give you an idea there of why we need to do this. But again, the strengths of this are I have, definitely in the government world, the government, be it Canadian or American, expects projects to do performance trending. And this is a fairly simple but robust method so that you don't have to necessarily be a Six Sigma black belt or hold a master's degree in statistics. It does help if you have access to somebody with that level of knowledge, But, you know, the Japanese have done this very reliably in terms of training their own workforce to make the charts. I had a secretary actually work for the vice president of safety at Hanford. She wanted to, you know, learn some new things, and she actually made 300 of my safety charts per month. Now, she didn't know how to baseline a chart or when to rebaseline, but she knew how to count the, you know, update the charts and count to 7 and say, hey, Steve, I got one of those 7 things. What do we do now? So people can understand this fairly quickly. And again, this has gone very well received by the Crown, as they call it up in Canada. And we've also already made a lot of performance improvements as a result of being able to understand our data. It says, oh, here's a question. Would you use SPC for data with very low populations or sample rates, like less than 10? Yes, I have done that. One thing, if you look at some of my writings, I will establish a baseline after the data have 3 changes of direction, which means literally I could put a baseline on after 5 points. If you have something look like an M, it goes up, goes down, goes up, goes down in the data pattern. If you Google some of my papers, you'll find that. I find those baselines, although maybe premature, they're before the 25, it's better to have them and say, do I have a handle on this process? I wouldn't go to the bank with it, the process is stable till 25, but I've had some initial baselines based on fairly small number of points that years later are still in effect. I guess I should say, one of my favorite phrases Davis Balistracci taught me was a baseline is innocent until proven guilty. So don't be afraid to set an early baseline. If the baseline is wrong, it'll be proven wrong by detection of a trend. So yes, I do use less than 10 data points on a chart, assuming this is a process we just started or we just, you know, got good data on and we want to monitor this through the upcoming years. Can I value, wait a minute, let's see, did I just skip by a question? Okay. Here's a good question. How do you use SPC for low frequency events where it's typically 0? In fact, just about exactly 20 years ago, I went to an ASQ national conference in Orlando with that exact question because I was faced with that with some Hanford charts. And I went around all the booths at the trade show, not getting some very good answers, but I went to Dr. Wheeler's booth, and Dr. Wheeler said, of course there's an answer to this. And what is it? Buy this book. Well, it's a book called Understanding Variation, the Key to Managing Chaos. And about 3/4 of the way through it, he talks about low-rate trending, where you plot a point for each event, but what you're plotting is the number of days since the previous event divided by 365. It actually has a lot of subtle benefits to it. If you plot the days divided by 365, you're in effect taking a logarithm if it's a low rate. And if you are dealing with exponential times between failure, it actually works quite well. I would definitely recommend Googling low rate trending. You may find one of my papers that references Dr. Wheeler's book. And if you're new to SPC, Understanding Variation, the Key to Managing Chaos is a great book. Can you comment on the value of measurement systems when analyzing the data for these scorecards? Well, I guess my comment would be, yes, garbage in, garbage out. If your measurement system is not measuring the proper thing, you'll get garbage out. However, I do find that, especially in this, not only has happened at Canada, but other places, I'll go in some place to something that's never really been monitored carefully. They may measure it, but nobody's ever looked at the data results. We put on a control chart and go, boy, this was an unusual month. And you go, well, what happened that month? And you find out, oh, the lead scheduler was on vacation, or other weird things happen when you put it on a control chart and say, well, why is this result unusual? Many times the result is unusual because of a data flaw. So data flaws tend to generate special cause variation. They'll trip signals. So actually taking a fairly unreliable measurement system, throw it into SPC will highlight the problems it has. I do find I have problems with people, their self-fulfilling prophecy. Well, Steve, the data's not really clean enough. Come back in a year after we clean up the data, and then you can analyze it. Well, guess what? I go back after a year, and they say what? Oh, well, we still haven't cleaned up the data. Come back in yet another year. The best answer I've found is just put the damn data on a control chart, see what it tells you, chase down the anomalies, and you will also send a signal to the people maintaining the data that somebody's paying attention to it, and they will go, oh, gee, in the past, I just went, oh, nobody's using this data. Who cares what the number is? Today's number is 10. They'll get the feedback of, yes, let's take a little better care with the data. Hopefully that somebody has said exactly. Oh, Brian, the person asked the question, so I guess I gave a good answer.
Okay, does anybody else have a question for Steve? I noticed we're getting closer to the top of the hour here, so we still have a few more minutes left.
Got a thanks there. So again, self-fulfilling prophecies can prevent you from analyzing your data. Whatever the data are, there's always going to be flaws with it. Throw it in, start understanding what the data is telling you, and if there's flaws, deal with them.
Okay, Steve, I'm not seeing any other questions come. It looks like a few people are dropping off, probably because they have something at 1 o'clock.
Yep.
If nobody else has any questions, we're pretty much, then I think we're just going to leave it here for today. One last reminder about Thursday, November 30th. It's our next webinar, our last one for this month. It's Innovation as a Management Response to Disruption, Experience from the Front Line of Healthcare Policy Reform. It's by Rebecca Anderson of the ASQ Richmond, Virginia section. So many of you have registered for that one, I see. Hope to see many of you 2 weeks from Thursday. Steve,
okay, and I'd like to thank everybody for listening in. Oh, I should give the disclaimer, this is open domain information since it was commissioned by the U.S. government. Feel free to make use of it. Of course, professionally, always appreciate an attribution, and if you do, if you are interested in it, be happy to provide any sort of unofficial help you may need.
Okay, thanks very much, Steve, for presenting today. It's very much appreciated. Looks like our official number for today was 81. I know we saw 84 come up on the screen, but 81 is the official number for today. Appreciate everybody's time today, and we look forward to seeing some of you, like I said, on the 30th. And until then, we'd like to wish everybody, those of you residing in the United States, happy Thanksgiving, and we'll see you after the holiday. And until then, hope everybody has a good rest of the day. Thanks a lot now. Bye now.
Bye.